Um, so my name is Sheen Brisals, and I am a AWS serverless hero. And I write about technology, AWS serverless. I speak at different conferences. I left my job last month, so I am kind of jobless at the moment. So, um, and the book I wrote with my ex-colleague, that's the one that Phil mentioned. Um, Before we get going with this talk, I don't know what you're thinking when I say enterprise, enterprise, enterprise. How many of you would say that you work for an enterprise? Quite a few. Okay. What would be your definition for an enterprise? Now, the answers could be different. One common theme often people say is scale. But when it comes to scale, scale is a very, like many words in English, it has different meanings, right? So if you ask zoologists, they would say, oh, fish scale or something. Or if you ask, material scientists, they say, lime scales. So it has different meanings depending on the context. So measurement is something probably we can relate to measuring an enterprise, size and things like that. So if we take that forward as our definition for scale, then again you have so many other different ways of interpreting. Now, ruler, sometimes in some places, they call it as a scale. Can I borrow your scale means can I borrow your ruler? And again, the weight or the map scale, and also we have the ratings from scale, 1 to 5 or 1 to 10. So again, even in the context of measurement, scale is, again has different meanings. It's because enterprises, we probably need to bring in a different word and different way of picturizing it. And that's where then we can slowly start to see why people are scared of enterprises or why people start to, talk about the scale. Because when we think of big enterprises or corporations, that's the large scale. And even in modern day, the cloud operations, we have the cloud scales. That's kind of become the standard measure. Oh, it's a cloud scale because it's all over the place. It's not just AWS, it's, Azure, GCP, everyone else, and all their data centers, dotted around the world. So one way of defining enterprise is like the breadth and scope of, the things they have, the product developments or the people and etc. It's not just internal all the time. Enterprises provide services and products to, external consumers and customers. So this is kind of slowly getting into an enterprise scale, visualization. Now, if you now focus on enterprise scale, the reason why we say this way is because of various other things become part of an enterprise. The people, not just the people like engineers, the people, the stakeholders, and everyone else kind of making that happen as part of the enterprise. The technology, so it could be legacy, it could be modern, it could be, on-prem or cloud, and you have the mix of, the technologies all around and the different locations. People speak different languages. You don't see people each other. They're all kind of, all over the place. And then there are so many policies and constraints and, regulations and things that we need to think of. So this is the reason why some of the technology adoptions get a special mention when we talk about enterprise, because we can't simply put something in an enterprise like how we do with a startup or a smaller scale, organization. Now, when enterprises are like this, their needs are also different. So if you think of technology enterprise, technology-based enterprise, you see all these abilities and more that are absolutely necessary in the modern world to survive. So that's another reason why the enterprise systems are often complex. The complexity there exists for a reason. It's not a kind of a disadvantage, but it is there. People know how to manage complexity in an enterprise. And then with all the modern practices and development processes, we have all these things. Especially in the modern world, to survive, you need to constantly push your product or features out there. It's a kind of constant cycle of doing things. If something breaks, you need to fix it, push it again. So there's a talk Sarah is going to give in the afternoon, 3 o'clock, I think, where she will be talking about how some of the teams manage such, relentless iterative process. So with all these things in place, how can you bring serverless adoption into an enterprise? So this is where it's good to take a step back and think whether your enterprise has some of these measures, or at least the thought process or thinking in place before diving deep into adopting serverless, or for the matter, any new technology. The first thing I would say is having the serverless mindset. Now, you must have heard this mindset word for a while. I think I learned this from David, who is speaking here today. So when he was at Liberty Mutual, where he introduced serverless, and that's where kind of I started to hear the serverless mindset. What is this serverless mindset? If you're someone new to serverless, you're probably thinking, what is it? So I will give you the answer in for 4 simple ways. Characteristics, those are the properties of the serverless technology, and the capabilities, that means the benefits these properties or the serverless services bring to your organization, and then some of the gotchas and considerations that you need to keep in mind, and then finally the collaboration. I will get to that in a moment. So when we think of the properties or the characteristics, you must be familiar with most of these things. I'm not going to go into the details of each of these things. And Luke, in his earlier talk, he mentioned the reasons behind adopting serverless post-null, and he highlighted some of the characteristics like scale to 0, or you just pay for the storage and things like that. So these are important properties or characteristics to understand. But once you know this, then you can understand the benefits. So this is where in a team, in an environment, in an organization, how this technology brings the benefits to the, to the company. So things like iterative development, for example. It's a beautiful technology, modern technology, that allows you to go incrementally, one step at a time. You don't need to, say, pre-purchase 100 SQS queues or, 200 S3 buckets. No, you just consume as you need for each iteration. So that way, it's a beautiful technology to, allow to do that. And when it comes to engineering diversity, it's like having engineers, their scope is beyond programming. They are not programs. That's kind of a wrong mindset in the industry, in teams. They should know now with serverless and modern cloud technologies how to secure things, how to, how the queue works, how NoSQL or SQL works. So they are part of the entire process of developing things, not just programming. This is good because when it comes to, cloud, for example, there was a question earlier on who is doing the IAM roles to Luke. So engineers doing all these things, they protect the services. They provide what privileges that, the different services need to have. So that's the reason why those characteristics bring the benefits. And then the most important part, the considerations. This is where many teams, many organizations get it wrong. Even the big corporates like Prime Video, for example, they do things all wrong and blame the technology. For example, we say serverless, but there are limits behind the scenes. We need to understand how much we can go up. I mean, of course, always there are, options to, ask for more quota or more, limits. But we need to understand that in order to make our architecture or engineering better. And cost. There are cases, use cases where it will become costly. I'll talk about that later on. We need to understand there is no point in just, using serverless for the sake of using and then costing a fortune. And then suitability. Again, I will touch on that later on. Whether it's the best fit for what your use case is or part of what your organization is doing. So these things needs to be in mind. And then the collaboration. So collaboration is like these days, engineering is more like a socio-technical kind of thinking. We can't simply separate technology or engineering from the people side of things. There is kind of a partnership between these two elements. So this is what, sometimes you hear this systems thinking. I don't know if anyone read this book. So it has a definition for, a system. It's kind of a, group of different things, a group of technology and people and so on and so forth. That is the way that we should see, the working with modern technologies. So this is exactly, for a while, I've been saying that when you think of serverless, you need to think that as a serverless ecosystem. Because we have serverless services, all the properties and characteristics I mentioned. Then we have frameworks and tools to build applications. And who is building those applications? Engineers building those applications. Who they're building for? They're building for stakeholders or businesses, okay? So they also become part of it. So that's the reason why I bring in this, this ecosystem analogy on purpose to make people understand it's not just doing few Lambda functions or SQS queues to get going. It's about making the understanding clear that everyone is on board and, working as a serverless, team. Because we need to think of new ways of doing things. We can't just, use the old legacy, waterfall or whatever we've been using. And the reason is why we need the mindset or mindset shift is because when we build serverless applications, it's basically a orchestration or a collaboration of many different services or managed services knitted with infrastructure as code or CDK or CloudFormation, etc., whatever you use to bring that application into, into production. So that's all about your mindset, set for adopting serverless. The second thing is to see whether you have the knowledge of the first principles. Now, first principles, I don't know how many of you heard of first principles. Anyone? First principles? So first principle is basically going back to the basics. Taking things, going like, the basic things, understanding those things and building from there. So this allows, once we have that sort of identities and the, the knowledge, then it becomes easier for us to, build things or innovate from there. Now, so that's exactly what I was saying, that these understandings are necessary. So technology becomes part of it, but technology in the sense like, building your serverless services. But before you get there, you need to have understandings of other things. They start somewhere else. And serverless first, you must have heard the serverless first term again, many times. People often think that serverless first means I should do everything in serverless. So there is a major difference. Serverless first is basically considering serverless for a use case or a thing that you need to do. Doesn't mean that you must do that with serverless. And again, Dave Anderson and their book, Flywheel Effect, there is plenty of talks about serverless first in this book. I would highly recommend, reading this because there's so much thought on serverless first and how can you bring serverless, what it brings to an organization, etc. Now, one of the reasons why I talk about the first principle is to make people aware. Not many people, especially modern engineers, they're not aware of some of the things that happened in the past. So, where do we start? Domain first. That's how you break your organization into different domains, or what is your domain? What's your, enterprise domain? And when you have your domain, set, then you can think of how can you set up your teams. Team first thinking. And then once you have team, you can think of APIs or the contracts and the services. You can kind of, switch things around, microservice and API. But the fact is, you need to have that sort of, knowledge and understanding. Event-driven architecture these days in cloud serverless, always should be there. And then you bring in serverless. So this is like roughly my way. I mean, you can always say that, you should be a DevOps first, should be there, security first. Yes, of course, depending on your enterprise use case, bring all those things in. So I wrote a blog a while ago, I think last year, more details about all these things. So what do I mean by this domain first and all sorts of things? Let's dig a bit deeper. The first thing is organizational pattern. And that's where this comes in, domain-driven design. How many of you read this book or any form of DDD book? Just a few, okay. So what this gives is the understanding of the different domains in an organization. So it could be an insurance or e-commerce or a different business domain. Then once you have the domain, you need to break it down into your subdomains and the core domains and things like that. So I won't go into the details. I'll stick with the subdomain just to give you a flavor of how the different, the division can happen. So if it's, insurance, you can have claims or quote generation or, purchase and things like that. E-commerce, similarly, there could be, several subdomains and core domains. Now, the point I'm trying to get to is once you get to subdomains, then there is something called bounded context. Bounded context is, in simple terms, is a boundary within which certain things make sense. In a DDD speak, it's a boundary within which a domain model is valid. Now, when you have different, subdomains and different bounded contexts, they will all have different sort of models. I think you get the picture now, how the boundary is slowly become a thing. Because these are all isolated, now it becomes easier to bring something else. Another pattern, that is a team pattern. How many of you read this book? Okay, again, just a few. So team topologies talks about how you can organize your teams. Now, it's a few weeks ago, a couple of weeks ago, I was at a conference, Fast Flow, where there's so many teams talked about, how they structure. So they have, team topology advocates, and here is an advocate. So they help organizations to structure in a way. So how does that help? So we've been to the bounded context. We have a boundary. Now we can bring the different types of teams or the ownership to those, the small bounded areas. So that's where the team topology comes in. Sorry. So now it becomes easier for smaller teams to operate within a boundary. So how a big enterprise can be broken down into smaller teams that are manageable. Once we have this, now we can bring in our more technical patterns like microservices, event-driven architecture. All these things can be brought in because within the boundary, we can now start building microservices or applications or however you develop your things within those smaller boundaries. So you have now boundaries and the teams. So this now gives you better control, autonomy, ownership to different teams to operate successfully. Now, how do they communicate? So you have all these different, broken down things and services and whatnot. You might be asking, how do they communicate? Because we have communication patterns. So typical contract and communication. Contract is the typical API one most of you must be familiar with. When it comes to communication, there are three common styles like synchronous, asynchronous, event-driven. And we have the typical APIs and the messages and events. And then we have patterns like orchestration or choreography. These are all essential when we work in serverless and also in an event-driven architecture. So this is a kind of a sample picture of how it may look like. So there are three domains. Within a domain, you have these sort of broken down sort of smaller areas where you have services owned by different teams and how they communicate each other via APIs. It could be an event broker, event bus, or whatever in between. So they're all like decoupled, but they still kind of come together to provide a business solution. Right, so the next one, the next kind of measure that you need to have is the suitability assessment. So this is very important when you bring in serverless into your organization. The reason is there are so many challenges. Now, in an organization, as I mentioned early on, there are several things. There are complex logic hidden somewhere. You have legacy technology. You have on-prem systems. And then you have people's problem because there are so many teams and they don't speak to each other, talk to each other. There is so much of complacency. Like, for example, teams doing Java or things for 2025, they don't want to move up. They don't want to change because they're so happy. So this problem is there. So recently I received a feedback, I think last week, from one of the readers who read the book, and he echoed this thing. His organization, he is a serverless expert, believe me, because there are engineers, they don't want to change. So they are finding it so difficult to bring in the new technology into their organization. This is the it's a fact that many organizations go through. So that's the challenge that we need to solve. Then we have this magic pill, problem. Because someone said, serverless is going to, make everything happy, all good for your enterprise, et cetera, et cetera. Then what they do is they get into this situation, the typical square peg, round hole. They find the heaviest hammer, try to drive it through it. And that's where things go horribly wrong. And again, serverless will get the blame because it's not good. So that's why it's important to assess. There are two things or three things I would say. First thing is, one thing you need to know if this will work efficiently in serverless. The second thing is, will this be cost effective? And third is also important. That's when, if you think, okay, someone like Sheen Brisals said to me that you must adopt serverless, but you should also validate his claim, whether he is advising because he is influencing, he is doing as an influencer, or he is kind of giving that advice as an alliance, he knows that whether it will work or not. So you need to validate that claim. So when I say efficiency, there are different ways you can think of efficiency. I'll just quote three things here. End-to-end efficiency, part, and deliberate efficiency in efficiency. I think there are one or two more discussed in the book. Say, for example, this is a simple one you must be familiar with. So imagine you are on a website, you are looking for the price of a product, or you're dropping something into a basket. As a user, you expect the performance end-to-end to be top-notch, because otherwise you will ditch and go somewhere else. This is where the end-to-end efficiency should be, absolutely good. Then part efficiency. So this is example, you submitted your order. Up until this point, the performance should be, the latency should be, top. And then once you completed the order, it's the background process of fulfilling the order, shipping, et cetera, et cetera. It can take a bit, time. It doesn't need to be a, millisecond, microsecond. It has time. So that means with serverless, you have the freedom to kind of architect your system accordingly. And then the deliberate efficiency, inefficiencies where you deliberately sometimes, put certain workflows as the high speed, certain workflows as kind of, lower speed. For example, product reviews at the bottom. It's okay if my review didn't appear for a day or 2 or 3. That means you can kind of, architect your application accordingly. So this thinking should be there. And business use cases, there are use cases where serverless won't do well. You need to recognize and accept that. Especially if you want to, fiddle into the lower level computing, or if you want extra high performance and GPU and etc. It's not the thing. Serverless is not the thing. So this understanding must be there. And then we need to have the engineering teams to cope with that situation. For that, you need to grow the team. For example, this is typical in many organizations. When they are, pressurized to develop something, obviously they go into this hire and assemble mode. That means they hire consultants from externally, they bring everyone together, they build the application, and what happens? Because they are consultants, they cost extra, they cost more, they disperse, right? Because it works. They got the product, it's running. Okay. What they do? They repeat the process. Hire, fire, assemble, fire. The problem is there are few engineers, their own engineers, sitting in the corner like onlookers. What they don't do, the organization leadership is like distributing the knowledge from the consultants or experts to their own internal engineers. What they then become, like the maintenance engineers, to look after the stuff that somebody else built. All right. So this is not good because there is no people growth in these sort of situations. So if there is no people growth, there is no team growth. That means there is no organizational growth. Of course, you can't build, bring in a technology and wish for it to succeed. So how can we do? How can we grow engineers? Briefly, you need to provide them the right environment. You need to kind of provide the support. You need to bring in the right engineers who can, take it forward. You need to have somebody as a, leader or a guiding, person. These teams that can look up and go and get inspired and move forward. And when it comes, then you provide the training. And of course, they grow and victories will come in. Even if it's small victories, you must celebrate. And then you spread the team. You have one example team here. You have a template to build more and more teams. So this is a way that you can kind of, grow engineers. The next measure, the final one, is your relationship with your, cloud provider. Also known as the popular term vendor lock-in. I know Luke talked about. So vendor being your cloud provider, and the lock-in means you are like, the platform that you are, locked to. So vendor lock-in in a kind of a definition way, this is what it is. Is everyone knows that you buy a database from a company, then you lock to that sort of database, even if it's SQL or NoSQL, et cetera, et cetera. It's so difficult to migrate SQL one database to another. Everyone knows that. Now, to me, vendor is something like this, someone who sells fruits and veg. I don't know how the vendor term came to be related to a technical side of things. So that's why we need to change your mind to see your cloud provider as a partner, not a vendor. Give a bit more respect. So here are the few differences, before I wrap up. So when we work with vendor, we work with a product mind. We buy a product. Whereas when we work with a partner or a cloud provider, service minds, they provide SQS or S3 or Lambda. These are all services that they provide. And the second difference is we operate with a buyer model with a vendor. We buy things, right? Whereas when it comes to the cloud provider, we consume their services, right? Then the cost, we bargain, we do the, I don't know, companies run weeks of requests for quote or requests for information, then debate who is cheaper, et cetera, because cost is always there. With the cloud provider, we operate with a growth mindset because that's the thing, why we are partnering with somebody, because we want to grow our business. Costs may not be cheaper all the time, but there is a trade-off. Luke beautifully mentioned a few things early on. And vendor, we always work with a third-party mindset. On the other hand, it's a partnership mind, okay? So these are the things I mentioned. And before I finish, I just wanted to give another example of an organization that successfully adopted serverless. And that one is Taco Bell. If you're here in the morning for Luke's talk, you heard how PostNL adopted serverless. Taco Bell is a different business domain. It's a different story. In the serverless book, they are there as case studies, I think 15 or 16 pages for each. So Taco Bell is there. So Taco Bell, you must be familiar, they have so many outlets all over the world, and they serve millions and millions of customers. And they started their adoption back in 2018. And the cost reduction wise is huge cost reduction for them. And two key people that I interacted to understand their serverless adoption story, Robbie and Vadim. Robbie, for example, he's quite visible in the community. He has given AWS, talks at AWS conference and things like that. One major advantage for Robbie, he always interacted with the community. He openly acknowledged that he benefited from Jan Kui, who is speaking here, and also Alex Debris, the DynamoDB expert. I had so many conversations with Robbie. Every time we meet, we'll sit down and talk through, okay, how did you structure the team? How can we do these things? So that community interaction to know what's happening, what others are doing, it's so important when we adopt serverless in a big scale. And this has been their approach. Like I mentioned, the small teams, iterative approach, guardrails and principle, very important because otherwise things can go, horribly wrong. And automation, always helps. And the advice to serverless adopters from their point of view, progression over perfection. That's, back to the iterative incremental approach and avoiding the big bang migration. This, I think, everyone understands now in the industry. And simplicity, less code. And I think there is some metrics in the, in the case study in the book where they talk about like 90 or 90% reduction in code coming from the old Java, the backend system towards the modern serverless implementation with Node and other things. And community, I mentioned. And going serverless first, with the understanding of what I mentioned early on, when you say serverless first, doesn't mean that, you always go there. So I close with this one. So if you're an organization, you're a part of an organization, you've been through sort of a legacy setup, you may still have legacy, you consider that you want to move forward. So today, you have technology, you have people here at ComSum to interact and learn on the technologies that you can, take it to your enterprise to benefit tomorrow. Serverless being one of them, and there are many other technologies as well. So you make use of your time today to take home, tomorrow's technology. Thank you so much. Thank you.
So Sheen is not going very far. He's actually on a panel discussion in this room next. What I would like to do, though, in the 2 minutes that we've got, is to find out if anyone's got a question right now. Yep.
Thank you. So recently there's been a bit of a pushback against cloud service providers. David Heinemeier Hansen recently published a blog post about saying servers have advanced so much that you can basically just buy some big servers and run your whole business off that. Do you think he's kind of missing the point about what you've been saying, or well, what would you say to him?
I didn't get the question, first part.
So there's a pushback now on cloud service providers saying you can do all this for cheaper using your own servers.
Right.
And it kind of goes against everything that you've just told us.
You can do cheaper with your own servers. That was, yeah. Okay. So someone recently said, even though people say that, oh, we use, EC2, et cetera, their image comes from S3, which is serverless, and they use IAM, serverless, et cetera. But the fact is, these days, I don't provide any comparison between an EC2 and Lambda. Because when it comes to a service, it's not just EC2 and Lambda, because there are so many other services come together, right? So that cost calculation often I don't see. They just see that, okay, you can get your long-term contract to get how many EC2 instances for 2 years, et cetera. But what they don't tell you is how much engineering time spent keeping up your clusters and et cetera, and also all the other services they come along with it. Like if you're comparing API gateway, then you need to compare with something else, right? Or if you are using something else for SQS, you need to think of that. So that the totality of the cost comparison should come in. Only then we will know the reality. But of course, there are situations where bare metal EC2 will be cheaper. We should acknowledge that. And we can also bring that as part of the ecosystem. It's not like everything is serverless or managed services. For example, in my previous company, one of the team I worked with, there was a need to bring in a container because they required a long-lasting or persistent connection with event broker. So it's not AWS, a different broker. So in those situations, a serverless team doing mostly serverless also had container as part of the ecosystem. So that's kind of my way of answering your question.